Hello everyone. So I thought I made this video just to go through all of the dot points relating to ions, ionic bonding, and ionic compound. I am going to go through each dot point, and I'm going to make a timestamp of the each dot point so you don't have to watch the whole video if you only need clarification on some of them. So this is the very first one, which is explain what ions are and distinguish between cations and anions. So very simply, ions are essentially atoms which have gained or lost electrons and have a charge. So a charge is going to be in the form of a number and a sign, positive or negative, at the top right corner of the symbol for the ion. So for example, you can have something like Na plus. So this is the symbol. So this ion is a sodium atom and it has a charge of 1 positive. So you can see a sign here. If there is no number, it means that the charge of the ion is 1. So Na plus is the same as Na1 plus. You can also have something like O2 minus. So this is also an ion because it has a charge at the top right corner as well, and O represents oxygen. So these are examples of ions. They are just atoms. They have gained or lost electrons and have a charge. Cations are essentially positively charged ions. So anything that has a positive number at the top right corner would be considered a cation. And anion would be an ion that has a negative charge. So it has a negative number at the top right corner. So something like this, or I really okay, S2 minus, something like that. So that's the first dot point. The second one, understand why ions have a charge. Okay, so this is the reason. An ion has a charge because there is a difference between the number of protons and electrons in the ion. So let me just give you an example. Let's say I have a neutral atom. So a neutral atom is not an ion, and it does not have a charge, or you can say it has a charge of 0. So if I have a neutral atom of sodium, sodium is an element. In this atom, this atom is going to contain 11 protons and 11 electrons. Okay. Now, hopefully you remember this, but each proton has a charge of 1 plus. So if I have 11 protons, the overall charge of all the protons in the nucleus of this atom is going to be 11 plus. So you get a charge of 11 plus from 11 protons because one proton has a charge of 1 plus. Similarly, you're going to have an overall charge of 11 minus from the electrons because every electron has a charge of 1 minus. Okay, so if you have 11 plus from the protons and 11 minus from the electrons, the positive and negative charge will cancel out, so you have an overall charge of 0. I'm just gonna create more room here. So overall charge would equal to 0. So this is why a neutral atom doesn't have a charge. Now the difference between a neutral atom and an ion is that in an ion, the number of electrons has changed, so it's no longer equal to the number of protons. So if I have an ion of sodium, which is, okay, let's just write ion of Na. Now, the number of protons will never change. You cannot change the number of protons in an atom unless you have a nuclear reaction, which we don't look at. So you will always have 11 protons, which means that the positive charge in the nucleus is 11 plus. Now, a sodium ion or Na ion will lose 1 electron, so it will have 10 electrons. So if you have 10 electrons, the overall charge of the electrons will be 10 minus. So in this case, there is a difference between the positive charge, the overall positive charge, and the overall negative charge. So the overall charge of this ion is now 1 plus, and this is the reason why ion is going to have a charge of 1 plus. So the reason why an ion has a charge is because there is a difference between the overall positive charge and the overall negative charge of the ion. Moving on to the next two dot points, explain how and why ions form and determine what valency an atom will achieve when it becomes an ion. Okay, so the reason how an ion is formed by an atom losing or gaining electrons, so that's the how. The why, now this is not something that I touch on a lot in class, mainly because I don't want you to generalize too much, especially if you're going to do chemistry in VCE, because this rule that I'm about to tell you only works for the first 20 elements. But anyway, you can say that the reason why ions are formed is because atoms tend to form ions in order to have a full valence shell of 8 electrons. The valence shell, for anyone who forgot, this is the outermost electron shell. So in an atom, electrons are arranged in shells of different energy levels, and the outermost, the shell, the one that is furthest away from the nucleus, the one with the highest amount of energy, that's the valence shell. So the outermost electron shell, essentially atoms tend to form ions so that it has a full valence shell of 8 electrons. This is called the octet rule. Oct is 8. So octet is to have 8, but it only really applies to the first 20 elements of the periodic table, which is why I don't want you to generalize too much. And it is really a rule of thumb rather than something that you can use to explain why ions are formed. But anyway, in the context of year 10, you can use it to determine the valency or the charge of an ion. So, okay, let me just give you an example. Let's say I have magnesium, and magnesium, the symbol is Mg, and I want to predict what kind of ion magnesium can form. Now, if you want to do that using the octet rule, you need to know the electron configuration of magnesium. In other words, you need to know how many valence electrons does magnesium have. So magnesium has an atomic number of 12, which means that it has 2 electrons in the first shell, 8 electrons in the second shell, and 2 electrons in the third shell. So this is the electron configuration of a magnesium atom. If magnesium wants to have 8 electrons in the valence shell, essentially the only way to achieve this is if these 2 electrons are gone. So if you remove these 2 electrons, magnesium will have 8 electrons in the valence shell. So magnesium is going to form an ion by losing 2 electrons. So form ion by losing 2 electrons. And if it loses these 2 electrons, the electron configuration is just going to be 2, 8. The atom has lost 2 electrons, so it now becomes a positively charged ion with a charge of 2+. I'm going to give you another example. So let's say I have fluorine. Okay, let's go fluorine. Fluorine has an atomic number of 9 and a symbol of F. So if I write the electron configuration of fluorine is 2, 7. 2 electrons in the first shell and 7 electrons in the second shell. So think about what is the easiest way to get a full shell of 8. It can't really lose all 7 because this shell only has 2. So in the case of fluorine, it's actually easier to gain an electron rather than to lose any. So it's going to form ion in this case by gaining 1 electron. So if it gains 1 electron, it will have an electron configuration of 2, 8, which fulfills the octet rule. So it has 8 electrons in the valence shell, and it will become an ion with a charge of minus because it has gained 1 electron. So that's how you can predict the charge of an ion, and it only works for the first 20 elements. Another thing I want to point out when it comes to this particular skill is that you can use the position of the atom or the element on the periodic table to quickly predict which ion it can form. If you think about the group is an indication of the number of valence electrons. So we have group 1, 2, and then 3, and then this is 18, 17, 16, 15, 14, 13. Okay. So group 1 has 1 valent electrons, which means that all of these atoms in group 1, except for hydrogen, all of these, because it's in group 1, so it has 1 valence electrons. Because it has 1 valence electrons, it will form 1 plus ion. So the easiest way for these atoms to achieve a full shell of 8 is if it just loses that 1 valence electron, so that the immediate shell before it is going to be a full shell. Now if you look at group 2, this is group 2. So group 2 has 2 valence electrons, which means that it is going to form 2 plus ions. Okay, so that's group 2. The thing is, this rule doesn't really work for these elements here, which the transition metals. So we're going to skip them, and we can go straight to 18. Now 18 doesn't need any electrons because it already has a full shell of 8 for the valence shell. So this one already has a full shell of 8. So does not form ions. Okay, so that's 18. If we move on to 17, this is 17. So group 17 actually has 7 electrons in the valence shell. This is 17, so 7 electrons in valence shell, or 7 valence electrons. So if it has 7 electrons, it will try to gain 1 extra electron to achieve the full shell of 8, which means it will form 1 minus ion. Okay, similarly, we're going to go to 16. I'm running out of, okay, let's go with this. So 16, there's no like pattern or reason for my color scheme here. So 16 has 6 valence electrons, and it's going to form 2 minus ion. Essentially, the atoms will gain 2 extra electrons to achieve a full valence shell of 8. And I think the last one that I'm going to do is 15, because the other ones actually don't form ions at all. I mean, there is aluminium, but you don't have to worry about that. So let's look at this one. So this is 15. And 15, so this group has, every element in this group has 5 valence electrons. So it will form 3 minus ions. Okay, so let's just stick with that. So you can determine the ions that an atom can form based on its position on the periodic table, at least for these groups. Okay, next skill. Know what ionic compounds and ionic bonds are. So ionic bonds, I think we've talked about this in class. Essentially, it's just the attraction between cations and anions. Cations are positively charged. So this is positive. And anions are negatively charged. So this is negative. So we're just talking about the attraction of oppositely charged particles. And you don't need to understand why they attract to each other. That would actually be a very hard thing to explain. You just need to know that they are attracted to each other. And an ionic compound is essentially a neutral substance containing cations and anions. So an example of an ionic compound could be NaCl. This is a chemical formula for table salt. This is called sodium chloride, and it consists of sodium ion and chloride ion. I'm pretty sure I did this drawing in class. So when you look at solid table salt, it's just going to have a lot of sodium ions and chloride ions in a solid. So it forms what is called a lattice in a solid. So that's an example of an ionic compound. And explain why ionic compounds form. Like some of these dot points do kind of repeat themselves. So the reason why is just because the cations and anions are attracted to each other. That's why ionic compounds are formed. So again, it's because opposite attracts. All right, this is the last dot point, actually no, second last, and I think this one is the one that most people identified that they need more help with. I'm just going to go through the method that I show you in class again, but keep in mind that there is more than one way to tackle these questions. This is just the one that I use, but you can YouTube and find other methods on the internet if my method doesn't work, or you can just ask me and I find another method to explain it. The other thing that I need to remind you is if you have to determine the number of cations and anions required to form a neutral ionic compound and write ionic compound formulas, if the question asks you to do any of these things, you actually need to use this table, which we will give you for your CAT and always. So not until you get to year 11 that you have to memorize this. Well, you don't have to memorize all of them. Okay, so whenever there is a question like this, make sure you find the ion names and formulas tables, which is in the core science booklet, page 108. Okay, so let's look at this again. So there are 4 steps. Identify the charges of the cations and anions. You're going to represent them using the bands, which is what I did in class. And then I'm just going to show you how it works. All right, so I'm going to use question 12 on page 105 of the core science booklet as an example. If you haven't done this question, maybe you can watch the video for part A and then try the rest yourself. So let's read the question together. You need to write the formulas of the ionic compound. So you know that you have to use this method whenever the question asks you to write the formula for something. And when an aluminium ion, Al3+, combines with each of the following ions, consider appropriate ratios to ensure the compounds are neutral. Okay, so let's go through the step. Step 1 is to identify the charges of the cations and the anions. Just a reminder, cation is the positively charged ion. So the cation in this case is aluminium 3+, and anion is going to be P3- or phosphate. Not phosphate, sorry, phosphide ion. You don't need to know the name. So Al3+ and P3- would be the charges of the cations and the anions. Step 2 is to represent the charges of the ions using bands of different lengths. So this is the method that I use in class. So I'm just going to use a different color as well, just to make it a little bit easier to see. So cations is Al3+. I'm going to try to draw a box. It's a little bit tricky on this writing pad that I have here, but I'm going to do my best. But you know, it's not going to be very straight is what I'm trying to say. So I really should have just used, you know what, that's all right. Okay, so let's say this is 3+. So this is Al3+. So one aluminium ion can be represented by one band with a length of 3 because the charge of this is 3+. I'm going to show you what the anion is going to look like as well. So the anion, I'm going to use a different color. It's going to have the same length as the cation because it has the same size. So it's 3-. So this is 3-. So the red band is for aluminium and the blue band is for phosphide. Okay, step 3, add extra bands if needed so that the total length of the positive bands equals the total length of the negative bands. So you don't actually have to do that in this case because the total length of the positive band, which is 3, is already the same as the total length of the negative band, which is also 3. So I only need one of this, one of aluminium and one of phosphate. Okay, and then step 4, write the number of bands used into the ionic compound formula. So the ionic compound formula is going to have aluminium, and because I only use one band, I'm just going to write 1 as a subscript, and then P, and I only use one of it, so I also will write 1 as a subscript. So you indicate how many of each band you're using. So AL1P1, which is the same as ALP. You have to simplify. So the final answer for this question is ALP. Okay, so that's part A. Let's do another example. I think I'm going through all of them. So part B, once again, your cation is aluminium, and your anion is, in this case, oxide, so O2 minus, and I'm going to use the band method again. So aluminium is Al3 plus. So I tend to do these marks just to show that each of these is 1. So this is 3 plus. And the oxygen, I'm going to draw a slightly shorter band for the oxygen. Okay, so this is 2 minus. So this is O2 minus. This is the length, and the other one is Al3 plus. Okay, maybe I wouldn't write that here. Now, this question, you do have to go through step 3, because as of now, the total lengths of the bands are not the same. The aluminium band is longer than the oxide band, so you have to add extra bands until the length of all the red bands equal to the length of all the blue bands. So let's say, for example, the oxide, the negative bands is a little bit short. So let's say I'm adding another one. The problem here is that you cannot do this. You cannot just say, I'm going to add a 1 minus, because you don't have any 1 minus ion available. The only thing that you can add is another one of these. So if I add one more, okay, because the length is 2 minus. So if I add one more of this now is longer than the positive. So that's not working out. So I'm going to have to add some more of the positively charged bands. Again, you cannot add a 1 plus band. You don't have any 1 plus. The only ion you have is a 3 plus ion. So every time you add, you have to add a 3 plus band, which creates a problem, because now that I add an extra 3 plus, my scale is not great, but just deal with it. Every time I add an extra 3 plus, this thing is now longer. However, I think if I add one more 2 minus band, that will solve the problem. Okay, so if you do another one, so now the total charge and the total length of the positive bands would equal to the total length of the negative band. So you need 2 of the positive bands and 3 of the negative bands for all the length to equal to each other. And when the lengths are equal to each other, it means that the charge of all the ions cancel out and you have a neutral compound at the end. So I'm going to write the name. So the cation first, so Al, and you're using 2, so Al2, and then O, and you're using 3, so 3. So Al2O3, it's going to be the formula for this ionic compound. I'm going to do one more. I think there are only 3 examples. So step 1, once again, I'm going to just write the cations and the anions down. So cations Al3 plus and anion, in this case Cl minus. If you see something like this is the same as something having a charge of 1 minus. And I'm going to represent the charge using different bands again. So Al3 plus, just going to do a long band of 3 plus. Okay, and then for the Cl minus, just going to do this one here. So this is 1 minus. So clearly the length of the positive bands and the length of the negative band are not equal to each other yet. So I need to add extra band, and I think this one's fairly easy to see. This one's always easier, because if your negative band's 1 minus, it's very easy to add so that the length of everything equal to each other. So if I add 2 extra 1 minus, it will equal the length of the 3 plus. And then you can write the formula. Okay, so aluminium, which is the red band, I only use one of it. And then I'm using 3 of the chloride. And then you need to simplify. Essentially, if the subscript is 1, you don't want to show it. So this is AlCl3. Okay, so that is question 12. You really want to practice this skill for as much as possible, especially if you're intending to do chemistry in VCE, because this is going to come back again. Question 14 of Core Science booklet, page 106, is another question that you can do to practice this. All right, this is the last skill regarding to ionic compounds that I am going to explain. And it is essentially to determine the types and numbers of atoms in a given compound. This is actually listed a little bit later, but you do need to do it for ionic compounds. And I'm just going to go through a question to explain what this means. And the question I'm going through is question 13 of Core Science booklet, page 105. So let's read the question. For the compounds below, indicate the different types of atoms in the compound and the number of each different type of atom. All right, so if you want to be very, very accurate, you once again need to refer to this table when you do this question. So if it's a NaCl, this is an ionic compound, it will contain, and see how there is no subscript here. So if you understand how an ionic formula works, you know that if it writes NaCl, it is the same as having one Na and one Cl. So the subscript, which is the number on the bottom right corner of an element symbol, indicates how many atoms of that element is present. So this means that you have one Na plus ion and one Cl minus ion. So sodium, so Na plus is here, you can find it from the table, and Cl minus is here. So you can use this table to determine the charge of the ion. I don't think we expect you to be able to figure it out from scratch based on the formula just yet. All right, let's move on to number 2, or part B. So again, if there isn't a subscript, it indicates that there is one of it. So there is one Si, and the charge of Si is, okay, anyway, let's just go one Si. The thing is, this is not an ionic compound, so you're not going to use it. So I'm just going to go one Si and 2 O. Okay. C is this one. Now, this is very interesting because on top of the subscript and the lack of subscript, you actually have a 2 here. This is a coefficient, and the coefficient must be multiplied to all of the subscript. Okay, so if I just have AlOH3 by itself, it means that I have one Al3 plus ion, and then you have 3 OH minus ions. So you can find Al3 plus and OH minus on this table. So that is if I have one of this. However, in this particular example, there is a coefficient of 2 in front of the ionic compound, and that means that you need to double this number. So this particular notation means that you have 2 Al3 plus ion and 6 OH minus ions. Having 6 OH minus ion means that you have 6 oxygen and 6 hydrogen. Okay, so that's the difference between the subscript, which indicates the number of atoms of the element right before the subscript. But if you have a coefficient at the front and you have to multiply it in with every single element in the formula. I think there's number, yep, this is the last one. Okay, so I'm just gonna go, I guess one way to do it is just to ignore the 3 at the front and focus on this first and then multiply the 3 back in. So if you just look at copper nitrate, CuNO3, 2, it contains copper 2 plus. So there's nothing here, so it means that it's 1. So you have 1 Cu2 plus, and there's something here, so there are 2 NO3 minus. Now, if you have two of this, it means that you have two nitrogen and 2 times 3, which is 6 oxygen. So in one compound of copper nitrate, there is 1 copper, 2 nitrogen, and 6 oxygen. So if I triple that, because there's a coefficient of 3 in front of the copper, you would have 3 copper 2 plus and 6 NO3 minus, which is the same as 6 nitrogen and what did I say 6 here? Oh, sorry. Is that? Yep. Okay, and then 18 oxygen. Okay, I think that's it. Oh, there's another part. Okay, you can do this yourself, I think. And that is it for the ionic compounds.